Week 3 constructions. Identifying constructions and using a compass. There are many different types of compasses. Here are a few that you might see in your classroom. But they all have 3 components the same. They all have a point you place on the center of the circle. Here you see the pointy end. There's the hollow circle. On a computer, you'll be able to slide this point to the center. And this is going to be that hollow metal circle. They also have a way to change the size of the circle. With this compass, you can pull the 2 pieces farther apart. This one, you can slide left or right to change the size of the circle. On the computer, you're going to be able to pull the circle left or right to change the size. And with this compass, you can choose any of the little dots along its side to choose the size of your radius. And lastly, they are all going to have a writing end. This is the place where you'll put the pencil or the circle is drawn. Here's the pencil in this compass. You'll be able to place your pencil in either of these 2 holes. On the computer, you're going to find that this point is what will actually draw the circle, and you can put your pencil into any of these holes to select the size of your circle. So let's copy a segment. That is, we're going to create a segment congruent to a given segment. Alright, looking at this problem, we're given line segment AB, and we're asked, which line segment is apparently congruent to AB? Step 1. Place the point for the center of the circle on A. Step 2. Choose the length that places the writing end on B. So we rotate over, and we're going to stretch our compass to hit B. Step 3. Use this length to draw a circle. Right? So we spin our compass and draw our circle, and we can see that this circle intersects the letter D. So the line segment congruent to AB is AD. Let's create a segment bisector. Right? The bisector of AB contains which line segment? So step 1, place the point for the center of the circle on the first endpoint, A. Okay. And step 2, draw a circle around A. So drawing our circle. Step 3, place the center of the circle on the second endpoint, B. So we're going to go all the way to the other side and draw our circle. So step 4 was draw a line through the 2 points of intersection. So we can see these 2 places where the circles hit each other. We're going to draw a straight line through them. All right. So the bisector contains EF. Now let's construct a line perpendicular to a line from a point on the line. We're asked, which line segment is perpendicular to line R and goes through point Q? Step 1. Place the point for the center of the circle on Q. Step 2. Draw a circle. What this does is similar to the last construction. We need 2 points that are the same distance from Q. So step 3. Place the point for the center of the circle on one of the intersections. So we'll slide to the right. And step 4, draw a circle with a larger radius. We want to go past that point Q. So we make our circle a little bit larger, and we draw it. Step 5, we'll place the point for the center of the circle on the other point of intersection, so sliding to the other side of Q. And then step 6, we'll draw another circle. Notice that we're keeping the same radius we used before. Step 7, we're going to draw a line through the 2 points of intersection. So I can see that the 2 large circles hit each other there, so I'll draw a line straight through. Therefore, because I hit point Z, the perpendicular line segment is QZ. Now let's draw a perpendicular line from a point not on the line. All right, Which point apparently creates the perpendicular to T from K? Step 1, place the point for the center of the circle on K. And step 2, draw a circle. Notice, when I drew this circle, I had to hit my line in 2 places. If you're not hitting the line in 2 places, you need to make your circle smaller. Step 3, place the point for the center of the circle on one of these intersections. And step 4, draw a circle. Step 5, place the point for the center of the circle on the other point of intersection. So we'll slide down. And step 6, draw a circle. Wonderful. So step 7, I'm going to draw a line through the 2 points of intersection. Right? So when I draw this straight line, I see that I hit point J. So the perpendicular line hits point J. Now let's create an angle bisector. One piece of pie is left for 2 boys to share. Where should the pie be cut to ensure each gets an equal piece? That is, I want to take that angle C and bisect it. So step 1, we'll place the point for the center of the circle on C. Step 2, we'll draw a circle. Step 3, place the point for the center of the circle on one of the intersections. So we'll slide to the right. And step 4, we'll draw a circle. Step 5, we'll slide over to place the point for the center of the circle on the other point of intersection. And step 6, we'll draw a circle. Now, if I take my 2 points of intersection and draw a line, I see that I hit point X. So if I cut the pie through CX, I'll get 2 equal pieces. Now let's copy an angle. This is an angle congruent to a given angle. An angle congruent to angle A is being constructed. Which ray should be used to construct an angle congruent to A? That is, we want to copy angle A onto the ray B. So step 1, we'll place the point for the center of the circle on A. Step 2, we'll draw a circle. Step 3, we'll place the point for the center of the circle on B. And step 4, we'll draw a circle with the same radius as we used on A. Step 5, place the point for the center of the circle on one of the intersections of angle A. So where that old circle hit, we place our compass. Step 6, we're going to stretch or shrink the compass so that the writing in hits the other intersection. So we're going from one point of intersection to the other. Notice that we are not on point A. Step 7, we'll move the point for the center of the circle to the intersection of line B with the circle. So sliding to our other line. And then step 8, draw a circle. Wonderful. So lastly, we'll draw a line through B and the intersection. So starting at B, we're going to draw a line through it and where the 2 circles intersect. I see that I hit point F, so which ray that would make a congruent angle would be ray BF, parallel to a line from a point not on the line. Jackie has sewn a stitch and needs to sew a parallel stitch that passes through point A. Which point lies on the parallel stitch with point A? Step 1, draw a line through A that intersects the given line. So we'll draw our line through the given line and A. Step 2, copy the angle, you can see the little base angle down there, to the intersection of the line and A. So we're going to be practicing the steps from the last question. So I'm not going to write down every one. If you're unsure of what I'm doing, go back to the previous question. All right, so we're copying the angle to point A. So I'll start by drawing my circle. Then I'm going to move my compass so that the center of the circle is on point A and draw another circle. For the next step, I'm going to take my compass and measure the distance between the two intersections, and I'm going to copy that distance onto my second circle. Now, if I draw a line between A and the intersection of the two circles, I have my parallel line. Right? Therefore, which point lies on the parallel stitch with point A? Point Z.